Welcome again. My name is Michael Wickerson. I am processing the vector components in Grasshopper for Rhino, and I have a series of scripts here. As we move through the math sets of vectors, I think we'll move a little quicker to what become much more intuitive, smaller applications of what we've learned within the math sets of vectors. I would jump in here and make everything visible, and then try and only select what we actually are clicking on. My first section is a vector point. Construct point is one of the most important nodes for creating your own algorithmic or computational geometries. And I would argue that constructing the point makes you consider what the point attributes may be. So constructing a point in set, and I just used the little gene pool node out of the params, and I'm going to take this off on group. So we can click those, and if you wanted to change up those points 100% change, 10% change, 1%, you could. But this guy just built a little point grid here. I've been lofted it and done what Daniel Kristof does so often to build a pretty interesting point grid and then align to visualize the data and the structure of this tree data, which is a list of lists. In doing so, I can grab that data and pull out the numbers as to what's happening. And so those points themselves can be deconstructed to get back at that data X, Y, Z on all the branches of that tree. Splitting the tree is pretty interesting because I can take this information of these points, the data, and I can mask it, which flattens in the node itself. And you can remove it, but that node comes flattened. I am choosing everything in branch. If we take a look at what's nice here is to use your param visualization tool and have a look at what's happening. Not just here, understanding the paths as these paths A, B, C. You can visualize the tree and see the paths A, B, C, and a branching of those paths. So I want everything on B and everything on C, and then I want one element selected from those, and those are the points that are being selected. Then I'm also finding the negative of what's not selected. So that's a nice way of using masks on split tree when dealing with points. And even though you can have some fudging when you do this, and you take a look at ones that have been excluded, if I was to take a look at the output of this, you'll see over here, I end up with, I'm going to see it in the param view, I'm going to actually see it in the panel tool. You'll see what's coming out is data that at times is producing nulls, which is why I like to use the clean tree to clean up what's happening as the data. And so in doing so, I can graph list items by flattening. I can say, give me index 4 and put a plane at that point, which happens to be dead center of what's happening. So try and follow going back to where your geometries are. Those are all your points and lines. Those are your points being constructed, and I put a plane right there in the center. In doing so, I can take my geometries and I can grab them now. I'll put them on double, and I can put a rotation of those specific to what I've done. And if you've gotten into box morphing and twisted box and things like that, this is a pretty good computational parametric control of what's going on behind the scenes and something like that. So I'm going to twist it and give it a little shake, do a little dispatch, find my distance. Not only am I going to take these lines and throw them through a beautiful multi-byte tool to grab some geometries that I have, the wonderful twisted control, and I'm not dependent upon the 8 corners of a box. I can find those distances between to see what's going on. I think I don't have any distances coming out currently, and it's defaulting, but it's showing me the data structure paths of what's happening. So that pattern itself gives you some pretty nice geometric control because you've taken points, deconstructed points, and played around with a little bit of shift paths and using the mask tools that I showed you in sets. So points and point grids become incredibly interesting when you're building new geometries and understanding how that computation is controlled. Group it again and set it back to the color that you prefer to show evidence that you actually have had a look at the script. Let's go down here and see what I did with closest line point. Let's take a look. Closest point and point. I think that's what I actually want. Let me just change that. Closest point and something just went a little funky there. I'll fix that up. Let's take a look at what I built here as a grid. I actually used the cells to start building a grid structure. I think we can go up to perspective view solely. Might take a little bit of time to run this, but I'm not sure why it's not overrunning. What I've done is I've created a surface from that, and I've grabbed the points from that. And I've said, points I haven't done anything with, I've moved those points and lofted them in a range. I put them up 67 high with a set of steps 4. And so I'm starting to think of building kind of a traditional kind of architectural unit. With the evaluate surface, I can actually go in and grab that surface, and I can evaluate anywhere on that grid if I reparameterize that surface from corner to corner, which is kind of nice to think about what I'm doing. I've got a little move function that I've played with. I put a bounding box around the whole thing, and I populated that geometry, thinking about what I want to do with it. Populated each one with a single, with a count that's respective to this point. So I put a little expression node in here. I've also populated geometry here with some seeds, so I can do-si-do and jump around and do a bunch of things. The seed count is here, so it should jump while I do that. I've used the closest point to actually find the closest points between here and the closest points between here, and draw lines between those and the original, and end up with these funky pieces of geometry that are dependent upon these points that are coming in. And I can start thinking about what to do with those geometries as I gain control of them. I go so far as to dig a little deeper in the split tree and having fun with the masks, and I'm stepping by even numbers and odd numbers in different directions, and I'm cleaning the trees so I end up with a loft between them, that even though plenty of data has gone into this, my bounding box says I can still grab a centroid, I can grab that volume, I can have a fitness to that volume. And it gets very interesting when you start thinking about using Galapagos as an optimizing tool for certain volumes to see this. I think I'll leave it for this exercise when I actually get in real time and show you that I can put in the genome any number sliders to actually have an effect. So I can go back to here and say, okay, what happens when I start to change these values? But since Galapagos finds the maximum and minimum, it might be a fairly simple program of optimizing those forms. The main thing I wanted to show was the pretty interesting geometries I'm coming out with without even offsetting yet. But there is a bounding box that's defined by these geometries. So let's just go back a little bit and say, okay, what happens if I change the masks to that? I end up with a different piece of geometry. This one's obviously more exciting, choosing different branches within the A and B, odd and even numbers with different elements on each. And then I can go back so far as to seed it differently, which I believe was this number. And I can jostle and create some pretty interesting ribbon forms to become architecturally interesting. And I still have 4 splitting it and lofting between it. What happens when I grab a number slider and plug in all of this data here, and then go back over to my geometries of this loft and say, okay, I want to have a little bit more effect on parametrically sliding this through and giving myself some larger forms. It kind of crashes when you get too big. But still, some of those sheets are moving and undulating, and you can take those and bake those in and think what to do back into Rhino. I have a domain here that would shorten it, it would fatten this, make this more ribbony as a structure, and you see there's a little bit of stretching and things that are happening here. You want to put it to render or possibly bake it in and convert it to a mesh to see what you have. I think it's a nice little script to play around with, and I'm just throwing on this plate bounding box and centroid for volume, so I can actually optimize that. I think when you're optimizing, you pull the fitness over the node you want, and then you pull your genome to control the, I wish I could do this, I say I think, but I'm definitely not. Let's pull that back over to a number slider that might have an effect on the domain. Obviously, if it's a full volume, let's take this through 0 to 10. It's going to max out, and I'll just run my little Galapagos because it's been a while since I did it. Did you work? Okay, let's pull it back over, plug it into 4. That number slider's been activated. I can double click while viewing. That's the problem, is I put it so I can actually visualize everything, preview off my lofted surface on, and I should be able to double click here and say, let's go into some solvers Let's maximize. We can enable the runtime at 0 hours and 1 minute. Let's go into solvers and start the solver and see what we end up with as we watch this geometry jump and jostle. And it's definitely found a way to maximize its form and nothing else comes close. It is thinking, I can stop the solver initially so that we're ending up with these similar bits of data. I've got a very clumsy octave form and ribbon tool that's just kind of exploded. I'm going to cancel that, and I probably am not going to mess around with the 10 slider. I'm going to say, what is the optimization on the x extends and the y extends? Let's go ahead and edit this back to a rational number and pull it between 3 and 4. Obviously, it's 3 and 5. 3 and 5. And we'll do 2 point. There it is there. Let's take it through another. Kind of clumsy, but not too bad. Maximize solvers play. There you go. It goes to its full setting, and it doesn't get any better than that. So you probably want to bring in some multiple number sliders to see what you have. Stop your solver as soon as you have an answer. And there it is. And take that to a little bit of a bake. There's Rhino. I'll do group. I've got this strange little shape that without doing my grasshopper, I could definitely go into my analyze tools. Just stick in there, and let's put it into a surface environmental map. Let's see what we have. It's kind of weird silver surface form that has been driven by a wide variety of thinking of closest point and building yourself some, imaginable pieces of architecture. Like I said, it's a bit clumsy. I'll try and slow it down, keep it a little more controlled. We might do the correct live feed of this. The bounding box is limited by number, so I'm stuck with kind of area and volumes. I wish I had a few more parameters on here that could drive that to its ideal volume. What I'm going to jump into is this one down here. Let's go over to enable, and we want to get rid of our baked object there. Got a little bit going on here. I must creatively been thinking of something. I do like zoom select, and now when I zoom select, I can rotate that around, or at least I should have been able to. Take this to enable and to preview on, and we'll only look at our geometry that we're selecting right here. So what did I do to start? Well, I was playing with grids. I played with square grid, rectangle grid, square grid, X grid, and I merged them all into this pattern that I have a series of points. But I've gone in here to call duplicate point just to show how it's activated. At any point that comes up similar in these 3 grid patterns, point grid patterns will disappear. And then I actually use the sort points to sort them along a curve. And my curve is being generated by the cells coming out of the hexagon grid. So I'm just playing around trying to get every node up and running. You've got curves that are driven here. You have curves that are driven here as they're sorted, and curves that are driven by these points that are sorted along that curve. I've also gone in and said, let's put within it a sphere. Let's deconstruct the breadth edges and grab one side, which happens to be the top. So think about the data that I have here and the data I have here. With the shift key, I'm probably going to do a project point. And all the points are going to fly up in the z direction, and whichever ones hit here have to shape to the surface that's selected here. And you probably are used to projecting geometries onto surfaces within Rhino. I'm going to clean the tree and get rid of the ones that are gone. I could sort them if I want, and I can interpolate through them and get another geometry on top of that surface. Then I go so far to say, let's take this curve and use the variable type tool, throw it through a graph mapper with a certain range that adheres to the number -1 of the steps to the range. And you'll see you can start grabbing some pretty interesting graph mapper control over that line and curve. And usually there's no real outcome in my mind before I start activating all of the nodes. And I do encourage people to get everything up and running and literally sit with the vector pad, go into points. Don't avoid the ribbon nodes to say what do they actually do. At least be able to write a script 12 to 24 nodes that can get everything up and running. And I have a few fancy little tricks that make visualization a little more interesting. I'm going to try again on just selecting this, but because it's a Grasshopper script, I'm not baked in the Rhino. Let me grab a little quick bake. It's kind of nice. Leave the Grasshopper window. Now I can use my zoom. Select. A little bit of control over this strange geometry. Projected, sorted, called points. Working within a quad sphere and also working here. And if you start to think about these things and want to find a way to make them exciting to look at and view, I would just go into my Properties tab without going into the animation tools, which I'd like to show at a later time as well. Because front-end stuff is always kind of fun. Go into your Properties, change up your, let's go down to 20 on the lens length, and that allows us to jump in here and start to move through and experience this piece inside and out as we start to open it up. And I like to play with my lens length, especially with geometries that are computationally created as opposed to statically created through Rhino. You could have done most of this there, but the best thing about Grasshopper is you can go back and say, here's my form, I want to have a little bit of funk, lock my solver, and I want to move this up to 6, and something just broke within it. Well, let's see if it comes back on. There we go. I've grabbed another structure directly above it, which is ready for another bake. And I don't have to go through the whole process of scripting it all again in Rhino. So let's jump in here, do one more bake, and there it is. Leave the script. I've got these two very nice hovering forms that I could enter into and explore at a very interesting length. And if this becomes kind of a spatial study and you like the render, let's just go a little farther. Let's take our spaceship and take it on a trip. Both these items, I'm going to go to my Layers tab. Sometimes I dream and have fun in this whole thing. We're going to have a path. What I do want to do is take these geometries and change them to this layer and lock them so I can't touch them. And now I just want to have a little bit of a flight path in my spaceship as I fly around through this, taking a look at it, and way at afar, have a look at what I'm looking at. And there's a couple of nice nodes in here that I use quite a bit now. Show toolbar, animation, animation preview, and animation setup. Let's leave that. They should pop back in here. If you grab it by the name, you can slap them in here. So after C-planes, animation preview, and this one's a little small. It's a subtle thing that I like to do. Grab the name, pop it in there. Now what you have, and let's not make it too boring, we want to be able to fly through this object, so let's lift it up. Let's edit some of the points. Let's edit these points, pull them down. Let's turn it around a little bit. Grab a couple of these points, move them here, and grab a couple others, move them up. And now what you have, it's going to be a little wild. Let's go back into here, and let's try and view that geometry again through a visibility animation setup. Let's choose the animation curve, and that will be okay. And let's preview the animation. I think it's going to fly by pretty crazy fast. Let's move this one over here. Oh, I love this screen-o-matic. The other thing to do is right before we get ready to do this animation with the map is these are baked on forms. They've been locked. Let's open them up again. Let's do another layer, and let's call that, well, I'll just default and just go by the color. Let's go on here and just select that curve, put that on the change object layer. We'll hide that line, but that's going to be the path of how we visualize this thing set at that wonderful lens length. And I am going to go back to my preview animation and take us on a tour. And you can see it's very fast. I just kind of lightning shipped all around. Animation set up again. Let's go here. Grab my target line. Let's do number of frames 1000. And that will slow it down by 10 times, I believe. Let's hit OK. Let's take that frame and turn it off. Let's go back to animation preview. There we go. Now I'm starting to zip around through my geometry and explore it and have a nice little animated view of coming to understand it. I'm going to go by it and then I'm going to turn around and put the face of it. And there it is. Whoa, I have one more pass and then we'll have some fun. It's always nice at this point to put it into render. And might be nice to take this and go back to analyze and peel on a little. I'm kind of playing around today because I'm in school. Let's play around with a little fuchsia and let's give it a little bit of analyze curvature analysis. Sorry, surface curvature analysis, which should be fun. And there you go. It's thinking because it's like, really? I'm like, yes, really. Let's grab that and shrink that one down. Keep these off to the bottom unless you want to add a tab somewhere. And let's do one more thing. I don't need Grasshopper anymore when I start playing like this. And I think this is fun for making animations. I learned it through the robotics lab as well. It's pretty fun. The curvature should be down here. We don't want to override that. Render's nice. Let's jump in and make the background pretty dark. That's fine. That's pretty horrible to look at. I've got a big lens lag on it. I'm even going to extend the lens lag to 10 just for fun. It's about as minimal as I go. But you'll see how this will really blast as we enter in. So we are Captain Kirk. We have taken a look. We're going to do the animation preview. Animation preview setup's done. We'll fly through this with 1000 count. There you go. This is how you end up experiencing your piece and having a piece. Alright, I'll just end with this and move through. Just finish up here. So if you're interested in playing around with this, I think this could be exciting. Thanks very much for watching. And one more visual.